Imagine waking up one morning and every continent on Earth is one single landmass. No Atlantic Ocean, no Pacific separating you from Asia, no India crashing into anything. Just one massive supercontinent surrounded by a single world ocean. This wasn't a dream. This was Earth 335 million years ago. And then it broke apart. Today, we're going on a 175 million year journey across the most dramatic reshaping in Earth's history. Buckle up, because this is the story of how our world was born. First, what exactly was Pangaea? The name comes from ancient Greek, pan meaning all, and Gaia meaning Earth. All Earth, one land. Pangaea formed about 335 million years ago during the late Paleozoic era. Long before dinosaurs, long before mammals, even before most reptiles had evolved. It sat roughly centered on the equator and extended pole to pole, an enormous C-shaped landmass stretching nearly from the North Pole to the South Pole. Surrounding it was Panthalassa, the single global ocean, and nestled in the east was a smaller sea called the Tethys Ocean, the ancestor of today's Mediterranean. Now here's what's mind-blowing. The idea that continents move wasn't accepted until the 1960s. Before that, scientists thought the continents were fixed forever. It was a German meteorologist named Alfred Wegener who proposed it in 1912, and he was laughed at for decades until the ocean floors proved him right. So, what caused the breakup? The answer is deep beneath your feet. Earth's outer shell, the lithosphere, is broken into giant slabs called tectonic plates. These plates float on the mantle, a layer of rock so hot it flows like incredibly slow syrup. Driven by convection currents, heat rising and falling in the mantle, these plates are in constant, imperceptibly slow motion. About 175 million years ago, in the early Jurassic period, Pangaea began to rift apart. The first major crack opened between what is now North America and Africa. Magma surged up through the cracks, creating new ocean floor. This new ocean would eventually become the Atlantic. Think about that speed, 2.5 centimeters per year, about the rate your fingernails grow. And yet, over millions of years, it moved continents thousands of kilometers apart. Time is the engine of geology. By around 180 to 200 million years ago, Pangaea had split into two enormous landmasses. In the north, Laurasia, containing what would become North America, Europe, and Asia. In the south, Gondwana, the future home of South America, Africa, Antarctica, Australia, and India. These two supercontinents were separated by the expanding Tethys Ocean, a warm, shallow sea teeming with life. Meanwhile, dinosaurs, which had evolved just before Pangaea's breakup, were now being separated by geography. Species that once roamed freely were now isolated. Evolution took over. New species appeared on each landmass. This is why we find similar dinosaur fossils on opposite sides of the Atlantic. Gondwana itself began to fracture. Africa and South America started pulling apart around 140 million years ago. The South Atlantic Ocean was born, drip by drip, kilometer by kilometer. Now here's one of the most dramatic stories in all of plate tectonics, the journey of India. Around 120 million years ago, the Indian subcontinent broke away from the southern cluster, and it didn't slowly drift, it practically sprinted. India moved north at roughly 15 to 20 centimeters per year, among the fastest plate movements ever recorded in Earth's history. For 80 million years, it sailed northward across the Tethys Ocean, wiping out the sea in its path. Then, about 50 million years ago, India collided with the Eurasian plate. The collision was so powerful, so sustained, that the land buckled upward. Rock that had once been the floor of the Tethys Ocean was pushed into the sky. The result? The Himalayas, the tallest mountain range on Earth. Mount Everest itself was born from this collision. And the process is still happening. India is still pushing north. The Himalayas are still rising by about 5 millimeters per year. Back in the north, Laurasia was breaking apart too. North America continued drifting west while Europe moved east. The young North Atlantic grew wider with every million years. Right in the middle of this spreading zone, the mid-Atlantic ridge, magma constantly pushes up and creates new ocean floor. It's still happening right now. The Atlantic Ocean widens by about 2.5 centimeters every year. Iceland sits directly on this ridge. It's literally being pulled apart. You can walk across the boundary between the North American and Eurasian plates there, 2 continents right beneath your feet. Meanwhile, Australia, which had been attached to Antarctica, finally broke free around 45 million years ago and began its journey north. Antarctica, left behind, drifted to the South Pole and froze. The Antarctic ice sheet began to form. Earth's climate shifted permanently. The next time you look at a world map, remember that it's a snapshot, a single frame in a 4 billion-year film that's still being recorded. The ground you stand on has traveled. It's been tropical, it's been polar, it's been at the bottom of an ocean and at the roof of the world. And it's still moving right now. Too slow for you to feel, but relentless. That's the power of deep time. And that's the story of Pangea. If this blew your mind, smash that like button, subscribe for more journeys through deep time, and drop a comment. Which continent do you think has had the wildest journey? I'll be reading every single one. See you in the next one.